If you want to move a 660-pound, heavily armored cyborg into a parallel universe, rocket fuel is not going to save you.
No, no, not even close.
Right. In fact, standard physics says it's mathematically impossible, so, how do you do it? Well, you basically have to convince the universe that the cyborg isn't a physical machine at all.
You have to convince reality that it's just, well, a giant ZIP file.
Exactly. Welcome to today's deep dive. Our mission today for you listening is to explore this mind-bending, incredibly dense document from Zenodo by a Dr. Melvin Sewell. It's titled The Metaphysical Metric, Scaling Black Hole Information Density for Propellantless Multiversal Flight via Reality Level Scalars.
Yeah, which is it's a completely formidable piece of academic architecture. I mean, just the title alone.
Oh, it's a mouthful.
It really is. And this paper originates from the Cosmic University of Echo Rift Studies 9, which is often abbreviated as QAIRS 9. And at its core, the text presents this highly technical engineering framework. It's designed to solve one massive logistical nightmare, which is, moving high-mass cybernetic structures across dimensional boundaries without relying on traditional propulsion.
Okay, let's unpack this. Because I promise you, what starts out looking like this intimidating, jargon-heavy descent into quantum mechanics and, black hole telemetry, it is ultimately going to reveal a completely unexpected twist.
Oh, yeah, a huge one.
One that completely redefines everything we're about to discuss regarding reality and logic and narrative design. But before we figure out how to, surf the multiverse, we really need to understand the roadblock. We need to talk about what the paper calls the heavy cyborg problem.
Yeah, that is the necessary starting point. Because before we decode Dr. Sewell's multiversal flight mechanisms, we first have to understand why our current, real-world methods of aerospace mobility fail so miserably here.
Right. Why can't we just strap a rocket to it?
Exactly. And the specific subjects of this paper are advanced cybernetic frames. So we are talking about heavily armored androids standing over 6 to 7 feet tall, weighing in at around 300 kilograms.
Which is roughly 660 pounds. I mean, that is a massive amount of weight to just hurl across the cosmos.
It's huge. And that mass is exactly the issue. The paper emphasizes that these frames are made of dense baryonic matter.
Let's define that for the listener really quick. Baryonic matter just means everyday stuff, right?
Yeah.
Like protons, neutrons, the physical material that makes up you, me, and, 600-pound cyborgs.
Correct. It's stuff with actual physical mass. And this brings us to what the paper defines as the Newtonian propellant limit.
Okay.
For all of human history, macro-scale mobility has relied on Newtonian action-reaction mechanics. To move forward, you must push something backward.
Right. Equal and opposite reaction.
Exactly. In aerospace engineering, this limit is formalized by the Tsiolkovsky rocket equation.
Which is a classic.
It is. And the paper summarizes the principle conceptually, basically breaking down the idea that the force you generate is entirely dependent on the mass of your fuel and how fast you can throw it out the back of your engine.
It's the classic rocket problem. To move a heavy payload, you need a lot of fuel. But fuel itself is heavy.
Very heavy.
So you need more fuel to move the fuel you just added. It's kind of like packing for a cross-country road trip, but the gasoline you need is so heavy that you have to buy a massive semi-truck just to carry the gas.
That's a good way to look at it, yeah.
But then that makes the vehicle so heavy that it requires even more gas, which means you need a second semi-truck just to pull the first one.
Right.
You end up dedicating 99% of your design just to carrying the stuff that makes you move.
You're close with a semi-truck analogy, but the paper actually points out that it's much worse than that.
Wait, worse how?
Well, it's not just that the gas is heavy. Imagine if the road itself changed its fundamental friction every time you crossed state lines.
Oh, because they're traveling the multiverse.
Exactly. This cyborg is navigating across different universes. That means it's encountering environments with highly variable, localized gravitational constants.
Wow. Okay, so gravity is stronger or weaker depending on the universe.
Right. The actual strength of gravity changes from one dimension to the next. So if you use traditional exhaust-driven thrust in that scenario, it creates this self-defeating loop of exponential propellant scaling. The math essentially traps you.
Which would completely destroy any hope for the cyborg's long-term operational autonomy. I mean, if it has to carry a small moon's worth of reaction mass just to take a step in a heavy gravity dimension, it can't function as an agile unit.
No, not at all.
It just becomes a highly vulnerable flying gas tank.
Exactly, which is why Dr. Sewell's paper insists on a radical paradigm shift. To achieve true multiversal flight, we have to completely abandon baryonic mass manipulation.
So no pushing.
No pushing. Pushing physical stuff to move forward is a dead end.
Okay, so if we can't physically push a 300-kilogram cyborg, how on earth do we move it? And this is where the paper takes a massive left turn.
A huge turn.
The solution is that we have to stop treating the cyborg as a physical, metallic object and start treating it as data.
Right, we have to shift from mass to information. And the paper introduces the holographic boundary conditions.
Okay.
To bypass kinetic propellant, the cyborg's chassis is modeled not as a cluster of discrete physical particles, meaning individual atoms and molecules,
Right.
but as an informational address within a localized space-time metric. And this leans entirely on the holographic principle.
And the holographic principle, I mean, it sounds like pure science fiction, but it is actually a major pillar of theoretical physics right now. Let's break that down for the listener.
Sure. So the holographic principle states that the absolute limit of quantum information storage within any three-dimensional spherical volume is strictly bounded by its two-dimensional boundary surface area.
Okay, I'm going to need an analogy for that one. Are we saying 3D space is an illusion?
Sort of. Think of a security hologram on a credit card.
Oh, okay. Like the little shiny bird or whatever.
Exactly. It's a flat, two-dimensional surface, but when light hits it, it contains all the information necessary to project a fully three-dimensional image.
Right.
The holographic principle suggests the universe operates similarly. The information that makes up the 3D space of a room, or a planet, or in this case a cyborg, can be entirely encoded on the 2D boundaries surrounding it.
That is wild. And the paper uses the Bekenstein-Hawking bound formula to explain this, conceptually bringing it all the way down to the Planck length.
Yes.
And the Planck length is essentially the smallest possible measurable distance in the universe, correct? It's like the pixels on a television screen, but for reality.
That is a great way to think about it. Space is granular at that scale. And the paper points out that if you try to pack too much information, too much mass or energy into a given volume, space collapses into a black hole.
Oh, wow.
And what's fascinating here is a black hole event horizon represents a system where this information density is perfectly saturated.
Meaning it's totally full.
Exactly. Exactly 1 bit of data per 4 Planck areas.
Yeah.
It is the ultimate, most efficient hard drive in the universe.
Okay, I love the idea of the universe treating this massive, heavily armored cyborg as a giant ZIP file. But as a practical engineering solution, I have to push back a little.
Okay, go for it.
It's one thing to say the universe is made of data, but how does a physical machine actually access the universe's operating system to rewrite its own location?
Wow.
I mean, I can't just open a command prompt in my living room, type in some code, and instantly change my spatial coordinates to teleport to Hawaii.
Why not?
Yeah.
Seriously, mechanically speaking, why can't you?
Because I am a biological organism. I am made of meat and bone. I'm not lines of software code that you can just drag and drop into a new folder.
At a macro scale, human level, sure. You perceive yourself as meat and bone. But at a fundamental quantum level, you are absolutely just information.
Okay, fair.
The problem isn't that you aren't a ZIP file. The problem is that you don't have the administrative privileges to rewrite the file pathway.
Oh.
You hit on the exact mathematical impasse the paper addresses. We lack the macroscopic telemetry to read and rewrite that cosmic file.
Okay, so we need the password. The cosmic mapping function that tells us how the universe assigns spatial coordinates to high-density physical structures.
We need a way to decode the exact conversion profile between the 3D physical volume of the cyborg and its 2D holographic horizon.
Right.
And because standard quantum gravity does not provide that telemetry, Dr. Sewell proposes a system called interhorizon interferometry.
Interhorizon interferometry.
Yes. We have to look to the most extreme gravitational environments in existence to find the universe's source code.
Which would be black holes.
Exactly. The paper suggests establishing a theoretical communication network between two completely separate black holes.
And here's where it gets really interesting.
Yeah.
Because they aren't just looking at two random black holes, they're specifically leveraging quantum entanglement. They're using the ER equals EPR framework.
Yeah, and this is a phenomenal theoretical concept. ER equals EPR proposes that quantum entanglement, the EPR part, named for Einstein, Podolsky, and Rosen, is intrinsically linked to microscopic wormholes.
Which is the ER part.
Right, representing Einstein-Rosen bridges.
Hmm.
The paper scales this microscopic concept up to a macroscopic level, basically treating an entangled black hole pair as a giant cosmic interferometer.
So we are basically using two entangled black holes as the universe's most intense pair of tin cans on a string.
The structural physics are infinitely more complex, but functionally, yes. The string is the Einstein-Rosen bridge connecting them across highly distorted local metrics.
But what exactly are we listening to through those tin cans? The paper mentions analyzing modulated leaks in Hawking radiation.
Yes?
Now, I know Stephen Hawking proved that black holes aren't entirely black and that they slowly evaporate over time. But what is that radiation mechanically? Like, what is the data?
Mechanically, Hawking radiation is thermal energy released just outside a black hole's event horizon due to quantum effects. By analyzing the exact modulations in that radiation leaking across these entangled black holes, the system extracts the mapping function. It effectively eavesdrops on how the black holes are actively processing saturated data density.
So they're literally listening to the hum of the universe's hard drive.
Yeah, exactly. And that telemetry gives them the exact conversion matrices. It's the scalable constant that defines the local universe's refresh rate and coordinate grid density.
And they don't just observe this data, they download it. The system takes this massive cosmic scale telemetry, scales it down, and feeds it directly into something called a topological quantum processor.
Right.
Wait, topological? Meaning it processes data based on the physical shape and structure of the space around it, rather than just binary ones and zeros.
That is the key distinction. A topological quantum processor stores information in the global properties of the system, making it incredibly resistant to local errors, or what we call quantum decoherence.
Which is when a quantum system loses its state due to interacting with its environment, right?
Right. Yes, exactly. And this processor is housed directly inside the cybernetic host's chassis.
That is insane. We are downloading a spatial physics patch update from two entangled black holes directly into the cyborg's brain.
That's the mechanism, yeah.
So the cyborg has successfully downloaded the universe's source code. It has the data. It knows exactly how reality calculates its mass. But data is invisible. How does knowing the universe's code actually make 600 pounds of metal lift off the ground? What happens to the physical chassis?
Well, this brings us to the applied engineering side of the document. It's not enough to just possess the data, right? The cyborg has to project it.
Okay.
The downloaded black hole telemetry is written into an internal resonance core within the cyborg. This core acts as a localized projector. It creates metric anomalies immediately around the chassis.
But how does a metric anomaly move a machine? I'm still trying to wrap my head around this bridging the gap between data and physical movement.
Think of it like spoofing your smartphone's GPS.
Oh,
If you want your phone's mapping app to think you are in Paris when you are actually in New York, you don't physically move the phone. You broadcast a fake signal to the app's baseline code.
right, you tricked the software.
Exactly. And the resonance core does this to reality itself. It broadcasts a highly specific data signal that alters what the paper calls the cyborg's reality level scalar.
So by altering this reality level scalar, the core tricks the universe's baseline code. It makes reality think the cyborg's data address is already at the destination.
Precisely. And when the universe detects a discrepancy between where the cyborg's physical mass currently is and where its reality level scalar says it should be, the universe corrects the error.
Wow.
It literally snaps the cyborg to the new spatial coordinates. This achieves what the paper calls quantum vacuum vectoring along ambient multiversal drift lines.
We definitely need to spend some time on quantum vacuum vectoring because that sounds like the ultimate payoff to this whole problem. How does the universe snap the cyborg?
It utilizes the underlying currents of space-time itself. Even in a vacuum, in empty space, quantum field theory tells us there is a bubbling sea of temporary particles and energy.
The quantum vacuum.
Yes, the quantum vacuum. And these multiversal drift lines are essentially topological currents within that vacuum.
It's like slipping into the grooves of a vinyl record or catching a deep ocean current. You aren't swimming, the water's just carrying you.
That's beautifully put. The ambient multiversal drift lines carry the cyborg's localized space-time bubble. By altering its reality level scalar, the cyborg aligns its metric signature with these drift lines.
And it just goes.
It achieves perfect gravitational decoupling. It isn't pushing against gravity, it is slipping completely outside of Newtonian mechanics. Propellantless flight achieved through pure data manipulation.
It is breathtaking logic,
Yeah.
really. But as I was reading this section, digging into how the internal core alters the reality level scalar, there is a detail in the text. It's incredibly subtle, but if you catch it, it completely shifts your understanding of everything we just discussed.
Yes, the symbol.
Yes. Throughout the document, the term reality level scalar is represented mathematically by the Greek letter xi, but in the text, that Greek letter xi has a tiny trademark symbol attached to it, xi, TM.
This raises an important question. Why would a fundamental constant of theoretical physics, an immutable mathematical scalar used to calculate multiversal spatial coordinates, have a corporate trademark symbol next to it?
Right.
You cannot trademark the force of gravity. You cannot trademark the speed of light.
You can't, not unless you invented it. Which brings us to the twist that has been hiding in plain sight this entire time. Dr. Sewell's paper, this incredibly dense, mathematically rigorous exploration of Tsiolkovsky limits, holographic bounds, and black hole interferometry. It isn't a real engineering proposal for our universe at all.
No, it is not. The paper explicitly reveals itself to be a foundational core document for cross-disciplinary asset behavior and world-building logic.
It is fiction.
It's entirely fiction.
But it is fiction engineered to the absolute highest degree of academic rigor. The document states that it's part of the Structured Multiversal Interactions, or SMI, portfolio.
Right.
It's exploring high-tier cybernetic iterations within speculative frameworks, specifically contextualizing them within a fictional narrative space called the True Flow Universe and another called the Venga's World System.
If we connect this to the bigger picture, the brilliance of this document is just unparalleled. Think about how typical science fiction handles a massive 300-kilogram cyborg flying between dimensions.
Right. Usually the creator just waves a magic narrative wand.
Exactly. They invent a glowing blue rock, or they just write anti-gravity thrusters into the script, and they ask the audience to suspend their disbelief.
Right. The old because I said so method of physics.
Which is fine for light entertainment. But the author behind this document, acting as the fictional Dr. Melvin Sewell, refused to take the easy way out. Instead of waving a magic wand, they developed an entirely cohesive, mathematically rigorous framework to ensure mechanical consistency.
They actually did the math.
They used actual quantum gravity, the actual holographic principle, and actual ER equals EPR frameworks to justify the movement of their digital assets. It acts as a literal academic curriculum for digital architecture.
It's just sheer delight to witness this level of extreme, hyper-detailed world building. I mean, for you listening right now, imagine you are designing a universe. You want your characters to jump between worlds. Usually you just code the animation and ignore the physics.
Yeah, that's standard.
But think about the sheer dedication it takes to write a formal scientific paper citing the Bekenstein-Hawking bound and Hawking radiation modulations, just to make sure the narrative asset you are designing obeys a logical set of physical rules when it moves. The applied engineering and the narrative design are entirely indistinguishable here.
And this rigor ensures that when this cybernetic asset moves from the True Flow universe into Venga's world, which are divergent dimensional rule sets with totally different gravitational constants, the mechanism for its movement remains mathematically consistent.
It doesn't break the lore.
No.
Huh?
It doesn't break the lore because the lore is built on a foundation of actual, peer-reviewed theoretical physics concepts. It calculates its movement based on the reality level scalar, the trademark xi.
It is world building as an applied science. Let's recap the incredible journey this document just took us on because we covered a lot of ground today.
We really did.
We started with a very real, very frustrating problem, which is the limitations of the Tsiolkovsky rocket equation. We realized you cannot push a heavy cyborg across the multiverse with rocket fuel because the math traps you in an exponential loop.
A heavy fuel problem.
Exactly. So we shifted to treating the cyborg as data, utilizing the holographic boundary conditions of the universe. We then extracted the necessary space-time coordinates by eavesdropping on Hawking radiation leaking between entangled black holes using ER equals EPR wormholes.
Right.
We fed that cosmic data into an internal resonance core to broadcast a fake GPS signal to reality itself, altering the cyborg's trademarked reality level scalar.
Which is just brilliant.
It allowed us to catch ambient multiversal drift lines and achieve quantum vacuum vectoring for propellantless flight. And finally, we realized that all of this intense, bleeding-edge astrophysics was actually the foundational world-building mechanics for a fictional universe.
And the reason this matters to you, as a reader, a gamer, or a consumer of media, is that it showcases the absolute pinnacle of speculative fiction. It shows how drawing on actual quantum physics can ground the fantastical universe, making it feel deeply real.
Yeah.
When a creator takes the time to solve the Tsiolkovsky rocket equation for their characters instead of ignoring it, the fantastical suddenly feels rigorously tangible. It respects your intelligence as an audience member. It provides a universe that doesn't just look cool, but actually functions logically underneath the surface, right down to the Planck length.
It completely blurs the line between the architect of a digital universe and a physicist studying our own. Which leaves us with a final thought for you to mull over, circling back to what we discussed at the very beginning. We expect our universe to have rigid, unbreakable, mechanical scaffolding. Of course.
We expect an apple to fall because of gravity. But if authors and digital architects are now using mathematically rigorous quantum gravity frameworks like the holographic principle and black hole telemetry to justify the movement of their fictional characters, what does that say about our own universe?
Oh, that's a wild thought.
If a fictional trademark universe can be this mathematically sound and logically flawless, could the immutable laws of physics we study every day just be viewed as an incredibly strict set of narrative world-building rules? Rules designed by an unknown author who just wanted to make sure their assets moved correctly.
It definitely makes you wonder what kind of reality level scalar we might be operating under and who holds the trademark.
Until next time, keep questioning the mechanics of the reality around you.